All right, more questions and answers. Hi, sir. Thanks for making great explanations. How do I get into PCB design? For me, as a non-electrical engineer, but I do a lot of repair. Is there a book or tutorial? Yeah, that's a hard one. Sometimes repairing, you'd like to make a little PC board to replace something that you can't buy any longer. So some skill would be needed for that. Certainly, part of laying out PC boards is learning the CAD program. You need to learn KiCad, some program probably free that you want, since it's kind of a hobby for you. So I would say, yeah, learn KiCad. There's tons of tutorials online. So go learn the CAD program, and then there really isn't a good tutorial for how you lay out a board to solve a particular problem, because it's different every single time. There are videos out there. Dave at AEV blog has done some things that kind of give you an idea of certain types of layouts, but it might not be the type of layout that you want to do. I really don't know how to answer that question other than just go do it. Just start doing it. The more PC boards you do, the more comfortable you become. The good thing about PC boards today is they're super cheap. You can get small boards super cheap from China from several manufacturers. Yeah, just start doing some. All right. This guy's got a ham radio without any reception. What type of signal can I put in the antenna connector? Is it possible to follow the signal? So I did a video on this before. I fixed up a Hammerlin receiver. I fixed up a kit radio, I think. I showed how you use a spectrum analyzer to go along different sections of the of things. Generally, I work backwards. So generally, a radio has an antenna and an amp and a mixer and a filter, and then maybe another mixer, maybe another filter, and then maybe an audio amplifier. So I always work backwards. So I inject an audio signal and see if I get a tone out the speaker. So put in, 1,000 hertz and see if your audio amplifier is working. Then insert, maybe the intermediate frequency here is 455 kilohertz. So inject a 455 kilohertz tone, see if that can go through. And then maybe your IF is 10.7 megahertz or 8.9 megahertz, whatever your internal IF, inject there. And then work backwards so you eliminate everything along the way. If you finally get to the front where the very first thing is that the antenna won't receive anything, the way to inject things into an antenna, I think it's called an RMA antenna, RMA dummy antenna. And it's basically a capacitor, it's a capacitor, and there's a inductor, and then there's like another capacitor. It's something like this. Forget that. It's something like this. Look it up. I think these are 0.0001, and these are 0.0002. And this is like 20 nanohenries, microhenries, something. Anyway, look it up, and you use this to inject signals into an antenna. All right. Can you make a BMS or charger-discharger for 18650s from discrete components? Yes, I could do that as a project. I'll think about that. It's constant current and then constant voltage, and it needs to switch, so that might be fun. I see a CW keyer on your bench. How was your experience to learn it? Difficult. Back in the day, you had to do 20 words per minute to get your extra. And although I could get up to 13 words a minute to get a general, it was really, really, really hard for me to do 20 words a minute. And the thing that helped the most was, so first of all, I learned the wrong way. I learned by looking at dots and dashes, like a dot dash is an A, right? That's the wrong way to do it. You need to hear da-da. You need to learn it audio. You don't need to learn it visually. If you learn it visually, then it inserts an extra step and you'll be too slow. So learn it audio. Anyway, yeah, it was really, really hard. The thing that helped me the most, I think also helped me with other languages, is to just play them in the background all the time. The thing that helped me was just to sit on the couch and read and just have Morse code in the background, just so my brain was always just hearing it. And it just became something that I became aware of. My brain says, oh, that's something that I'm interested in. I will just kind of listen to that. And then it started to hear things. It started to hear words and started to hear letters and stuff. And anyway, that's what helped me. Do you work on HF boat anchors? Yes, I hate anything with vacuum tubes in it, so you won't see me doing much of that. I worked on a 430 Kenwood, and I did rebuild a Holocrafters receiver, which was a big boat anchor. And those are videos online. So I have a question about a little thing. Many years ago, I was playing around, and I had the idea as to turn the relay on and off, and it sparked. And what's the spectrum? Yeah, the spectrum can be really, really high frequency. I don't know exactly what it is. It has to do with the energy of the spark and the quickness of the spark. And it says here people got angry. It splatters everywhere. So I don't know exactly, but it's bad. Let's see here. If I understood your comments, you built a buzzer. Frequency, can you get rapidly closed? Gap. This is the same thing here. A few hundred hertz. Anyway, yeah. Spark gap generator. The spark gap transmitter. Go back to the old days. In RF applications, let's see where to answer that one. Can I feed the serial output of a GPS module to a software shortwave transmitter and then receive it a long distance? Sure can. So the output of a GPS module is a burst of data. So you receive that burst of data and then you decode it. And that happens about once per second. So once you've decoded it, you can take out the things you don't want and just keep the thing you do want, like your coordinate. And then you can have a digital transmitter and digital receiver, right? So yes, absolutely. Very easy to do. My question, when you're showing a schematic, you waggle your fingers around. Ah, yes, I waggle my fingers around, I move things. Sometimes the camera goes off. Sometimes I mispronounce words like measure, and sometimes I say a lot. And I do all those things on purpose. You see, the YouTube algorithm doesn't care if you give a negative comment or a positive comment. It just needs to count the number of comments. And so all of these little tricks that I do make those people give me more comments. Okay. And if you're not sure what sarcasm is, you might want to look that up as well. Okay. Since you are into optics, what do you think the world of Ahazem, I think is his name. Ahazem wrote a book about optics, I think in the year 900 AD. And it was one of the classics. It was sometimes touted as the birth of modern optics, whatever modern means. Now, I believe that Ptolemy had written a book on optics several hundred years before this book. But that book seemed to have gotten lost. The book that this fellow wrote, there were many copies, and so a lot of people in Europe read it. And so it became a foundation. He was a really clever guy. I think my favorite thing about him was his quote as, if you really want to do science, don't believe anything you read and don't believe yourself. Have to prove everything. What about optics these days? So in my world, modern optics started in 1959 with a book written by Born and Wolf. And Born and Wolf basically took Maxwell's equations and derived all of optics. So it basically marries electromagnetism with optics, and everything falls out in this huge book. It's a giant book. It's really hard to read, really hard math. But that's modern optics was started in 1959. The type of stuff that I did, what came from a book in 1965, the title of the book was Modern Optics. And it was written by a guy named Smith. And I was fortunate enough to take a class where Smith taught the entire book in 1 week. So that was pretty heavy duty. All right. Thanks, ImsaiGuy. Thank you. Okay. Let's see here. Something that's been bothering me. Oh yeah, it's got cut off here. This guy wanted to know about AC. So in AC, it comes into your house, okay, and it comes in on 2 phases. So it basically comes in like this, and you ground this phase, and then you have 120 volts here, and you have 120 volts here, right? And he says, well, how does that work? If you ground out one side of AC, how does that work? So he's thinking of AC as a push-pull. These 2 lines are taking turns. One's pushing and one's pulling, and one's pushing and one's pulling. And if you ground one side, it can only push, it can't pull. Well, that's not true. It actually can do this, okay? So instead of this, if let's say they're moving back and forth 2 inches, okay? They're back and forth 2 inches. And this one goes up 2 inches, and this one goes down 2 inches, and this one goes up 2 inches, and this one goes down 2 inches. So if you just put one down, now this one can go up and down 4 inches, and it does the exact same thing. So kind of think of it that way. The other thing to help you think of it is it's alternating current. The current in one wire can go forwards and backwards. So the other wire doesn't have to do anything. It goes back and forth. The other way to think of it is on the low voltage side. So think of you building a power supply, okay? And you have 120 volts on this side, but on this side you have 8 volts AC, okay? 8 volts, 8 volts AC. And you're going to rectify that and make a 5 volt thing, right? You're going to put a bridge rectifier over here with a capacitor and all that kind of stuff, right? And what do you do with these things? Well, you tie one side to ground, okay? That's very, very common. So how does that work? You're doing the same thing here as you did over here on the mains. You're still grounding one side of your AC, and it still works. So maybe that will help as well. All right. Yeah, here's a funny question. What's your go-to dance move? All right. So I will answer it this way. Back in college, I was a square dancer. There was a Grange outside of town that had square dancing, and a lot of the college kids did square dancing. And I got super good at it. And there was different, this beginner, intermediate, and blah, blah, blah. You keep going up and up. The highest level of square dancing is something like experimental or something like that, where the caller can just give you anything at all, and you are good enough to do it. And so, yes, square dancing. Okay, I know someone has probably asked you how you started your interest in electronics, but I want to know how you end your interest in electronics. Well, 2 things will happen. I will die. Okay, so that might be one thing. Probably the most likely. That's probably the most likely. The other thing that I have a habit of is hobbies. I think somebody asked me about my hobbies. I have a hard time doing 2 hobbies at the same time. And so I know somebody asked it, so I'll answer it now. So hobbies other than electronics, billiards, pocket billiards, I've done since high school, and I'm really, really serious about it. If you're serious into billiards, I have a Titleist conversion done by Paul Drexler, so that gives you some idea of how serious I am about it. Photography was a big hobby. I had a darkroom when I was a kid. I had a darkroom when I got my first house. Now it's all digital, but yeah, photography is always a big one. I used to autocross and drag race and stuff cars. So rock climbing I did that for decades. So whenever I do a hobby, I can only do one at a time, okay? And there's a couple hobbies that I can do at the same time. So billiards, I've done all the time. Music, I'm classically trained. I play guitar, mandolin, banjo. I play a little piano. So music is a big thing. And sometimes I dabble in that. But if I really am hardcore, I flop. So I'll do nothing but music, and I'll ignore everything else. Or I'll do nothing but billiards, and I'll do nothing else, nothing but photography. I'll just do nothing, right? So the one thing that could kill my interest in electronics is some hobby or a re-entrance of an old hobby that completely consumes me again, and I will just stop. Okay, there's your answer. What's your favorite capacitors? I talked about my favorite resistors. What's your favorite capacitors? 0.01, 0.1, and 10. So 0.01, I have 7,000. 0.1 is just a really great value. And 10 microfarads, I have a bunch of them. So I needed something big. So those are those. As a way of a hobbyist, I really enjoy. Thank you. How do you feel about the dislike buttons counter being publicly disabled? I think it's stupid. How can you produce a video every day? That's a good question. I didn't start out that way. My channel started out having one maybe once a week or something. When COVID hit, I had nothing to do, and so I started doing more videos, and they started to stack up on me. And I had like a year of videos, and I went, oh, I can't do that. I need to start releasing them. And so I started releasing them quicker and quicker and quicker. And so finally I started doing them every day just to get out of my pile of videos that I had already done. And then it just kind of stayed at that level through COVID because I had nothing to do. How do I physically do it? I don't do any prep. Rarely do I do prep. It started out as a video blog, and I kind of still view it as that way. I sort of do what I would normally do in the garage. I just turn a camera on. And so it doesn't take a lot of extra effort. And if it ever did take extra effort to do the editing and the scripting and all that stuff, I would stop. I would not do these videos. So these videos are off the cuff. They're very quick. They're only 5 minutes long. Maybe it goes up to 20 minutes, but they're supposed to be short. I don't spend hardly any time at all editing. I'll just cut out certain portions, put in the trailer and the ending, and that's it. Right. So. There may become a time where I don't do it every day, but for now, I'm still piling up videos. Sometimes I'll shoot like 3 videos in a day, so that helps as well. Okay, there we go. That's it for that. All right, I wanted to go back. I wasn't happy with an answer that I gave about what does it take to be a good engineer, and I wanted to give a couple examples of bad engineers. Just so you know. So I used to be a manager, and I've read lots and lots of resumes, and I've interviewed lots and lots of people. And like I said, passion is very important when I interview people, and it is for others as well. So part of the interview process is seeing if they know what they know, okay? And I've washed out PhDs because of that. And I remember there was this lady who came in. The way that we interviewed is you came in the door and you were expected to give an hour presentation on some topic where everybody went to that meeting. And then after that hour presentation, then you went for the entire day and you interviewed with everybody. So she gave the presentation in the morning, and I looked at a graph she had. She had this graph of this data. And so she had a bunch of data. And she says, okay, that fits a straight line, right? And this was some value. Let's say it's 10, and this is 1,000, okay, something like that. And she says, here's the data. And so I looked at the graph, and in my training, you always look at a couple things. You think about, this is like Einstein's thought experiments. You say, okay, what if it was 0? What would happen at 0? Okay? And then what would happen at infinity? What would happen at those two extremes? What would be going on? And does it make sense? Does it make sense what happens at 0, and does it make sense what happens at infinity, right? And so I asked her, because it didn't make any sense what happens at 0, okay? It didn't make any sense at all. And so I asked her, I said, so if you extend this data to 0, what's going on? And she had absolutely no answer for it. And in her particular case, it was because she did the work of her professor. Her professor wanted to get a paper and research. And he had the student do it, and the student wrote it up and got co-authored on it. But the student never took the time to learn it. They weren't passionate enough about it. They didn't own it. They didn't absorb it. And so they couldn't answer simple questions like, well, what happens at 0? What happens at infinity? So we kicked her out. I mean, she lost that interview. It's too bad, because was it her fault? Partly because she didn't have the passion. But I blame the professor probably for doing more harm on him. The other thing I wanted to say about being a successful engineer or passing an entrance exam or whatever was another one where when you go in for an interview, they will ask you a bunch of technical questions, and then there's the lunch interview. The lunch interview has to do with, can we work with this person? Is this person fun to be around? Can we relate to this person? Things like that. And I remember we had this one person come in, and he seemed to know something about what the work he was doing. And at lunch we said, oh, so what do you do as a hobby, right? People ask me that. What are your hobbies, right? In most of the engineers I've run across, there's a, I'm tapping my fingers. There's a commonality. A lot of engineers are interested in cars. A lot of engineers are interested in music. A lot of engineers are interested in outdoors things like bicycles or skiing or some type of physical sport. There's like these reoccurring themes that people kind of all sort of are kind of the same. And so when we asked this guy, so what are your hobbies? It was like the first time anybody had asked him of that. And so I said, well, what do you do on weekends? Oh, I guess I like to rollerblade. Oh, well, why, how'd you get started in that? Why do you do that? Blah, 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 blah. Oh, because my girlfriend likes it. Oh, okay. Okay, how about engineering? How'd you get into engineering? What sparked you? What things did you do as a kid that maybe, oh, well, I needed a profession, so my dad thought engineering would be good. Okay, so his dad tells him to go be an engineer, and his girlfriend tells him to go roller skate. He has no original thoughts for himself, so he got kicked out. So anyway, like I said, you got to have a passion for this stuff. So anyway, just leave you with that. Thanks for all the questions. Thanks for being a viewer. Thanks for subscribing. Thanks for liking. Thanks for commenting. Thanks for my Patreons especially. Yeah, thanks to you guys. This was kind of fun. I didn't get a lot of questions that maybe I was hoping for, but so might do this again in the future. Always feel free to ask me questions along the way. You don't have to wait. Yeah, it did bring up some ideas that maybe I want to think about, and some maybe some future videos.